the first of the Burn the Subs deep dive series. Keep in mind, I'm not an expert, and this is a huge learning process. Any mistakes or missteps that I make were specifically designed to test you. Ah, shit! So how'd this all come together? I didn't exactly go out and buy a kit. Like most good projects, Burn the Subs started with a simple idea and a complete lack of understanding of exactly how complex that simple idea is. What is that called? It's Dunning-Kruger? I wanted to emulate streamers that have some physical readout of subscriber names. There are various methods: whiteboards, TVs in the background, LED scrolls. All that is kind of boring though. I had to make something to show appreciation oh bother style. Something prone to fail, fun to watch, and slightly too moderately dangerous. I was messing around with the idea of doing other CNC projects on stream, smaller moving devices. But if my high school art teacher taught me one single thing about project design, it's that art needs to take up a lot of space. So the idea was to laser etch names onto a physical wooden board. Once the board fills up, I have an art for the wall. I have a lot of crap in my lab, so I wanted to use as many pre-existing parts, garbage, as possible in order to automate it. Talking about this stuff now makes it seem like I have all these solutions, and as if this was the best way or the only way to do it. That's not the case. The reality of Burn the Subs is that every single part of this build came about from constant, frustrating, sometimes hilarious, failure. So let's start with the hardware. The board is made almost entirely out of MakerBeam. I've got a soft spot for this stuff, and it's actually pretty handy. I already had 400mm MGN12H, I had to look that up, linear rails, which luckily take the same bolts as the MakerBeam. Timing belt is just whatever size I had, along with a whole mess of other timing belty, automaty stuff. What I didn't have was enormously long linear rails and MakerBeams. I had to order all of that. To weave all this MakerBeam into a frame, I have all these little angle irons with bolt holes in them. Like, I have a lot of these things. Where's this all coming from? There's more in this bin? What the f? The timing chain itself is just standard 2mm pitch, 6mm timing belt. Pulleys are sized to that. The axis hard limits are a result of the blocks I used in order to mount the pulleys. Limit switches are just roller arcade switches that I bent to be the right distance. The y-axis gantry is mostly ad-libbed as well. The long rails were perfect to mount the tentacle of respiratory health to. Could be a bit more elegant, but I mean, I guess it works. You'll notice that the laser doesn't actually have one of those big heatsink blocks around it, because I kind of broke a drill bit inside of it. It wasn't my fault. Anyway, I had a bunch of heat pipe coolers from laptops lying around, so I decided to flatten part of the brass diode holder and then press that against the heat pipe. It doesn't really need all of that cooling, but we're also slightly overdriving the laser. Don't tell anybody that it's actually a 1.4 watt laser. It does get pretty warm though. Other actual real professional XY tables use something called drag chain to carry wires around the axes without producing a gigantic knot of cables. The orientation of our table, and I use the term very loosely here, is such that I had to kind of get weird with it. The addition of a few angle irons actually helps gravity do its work and keep those drag chains neat and clean. It's an absolute nightmare to feed wires through these things. It also just so happens that the spacing of the X-axis motor rails is not only just about Raspberry Pi sized, it's exactly the size of the motor controller board. I made a little open-air enclosure for it just to be fancy. It's not exactly keeping dust out, and actually the acrylic sheet I used was too dark. I promise you that there's text and indicator lights and all kinds of cool stuff behind it. Onto the motors. The donor vinyl cutter provided us with two standard-sized stepper motors, a NEMA 17 and a NEMA 23. Stepper motors move in a very precise degree increment when you send them pulses, and this is the entirety of my knowledge of stepper motors before this project. In the interest of being honest here, I have a confession. The only reason these steppers use a belt reduction is because I kept seeing belt reductions in other projects using stepper motors. So why not? The extra torque and accuracy can't hurt, right? Belts were at least cheaper than Acme rod. And it's not like I had this stuff lying around the shop. I had trouble finding an adapter from the NEMA 23 motor to the axle that I have. So I got a coupler that was smaller and put it on the lathe. I'm just kidding, I don't actually have a lathe. I drilled that sucker with a vise and a prayer. That's why it's terrible. This little wiggle motion that you can see in the motor is probably stressing out the screws in the maker beam. I'm guessing it's going to be a big failure point. Once it breaks, I'll machine a proper bracket, probably. I don't know. To mount this sucker to the wall, I used pine boards. The pine boards are screwed into 3 studs on the wall, and I actually just drilled through the maker beam in order to mount those to the pine boards. In addition to this, the maple target board is actually just screwed to the pine board. So nothing is going anywhere-ish, and the maker beam frame is only responsible for holding itself up. That's about all there is to the physical part of the board. We'll talk about the electronics next, and then it's on to software. Thanks for watching.